Good morning, students. So today we are going to discuss the wave nature of the electromagnetic radiation of the chapter structure of atom. Right, in the last class we discussed about the atom, derivation of the atom, right, and also the subatomic particles, discovery of the subatomic particles and different atomic models and their arrangement, subatomic particles arrangement. In today's class we are going to study about the wave nature of the electromagnetic radiation or electromagnetic wave. Now, how this electromagnetic wave is produced? Say for example, when there is a still pond and you throw a stone, if you observe, it produces waves in it. And there is an empty drum and you give agitation in it, you provide disturbance in it, it produces sound waves, right? It produces sound waves. And like in the same way, even this, when a charged body vibrates, it produces both electric field and the magnetic field, right? When a charged body vibrates, it produces what? Both electric field and the magnetic field, which are perpendicular to their propagation of the wave, direction of the wave. Let us see once again the wave nature of the electromagnetic radiation. Like the sound waves, right, like the water waves, the charged body produces electric field and magnetic field. Electric field and the magnetic field, which are perpendicular to the direction of the wave. Let us see it once. Here, when a charged body vibrates, it is going to produce the electric field and the magnetic field. It is going to produce electric field and the magnetic field, right? Electric field, magnetic field, which are, both of them are perpendicular to each other and also to the direction of wave. Electric field and the magnetic field are perpendicular to each other and also perpendicular to the direction of the wave, right? When a charged body oscillates, when a charged body vibrates, it produces electric field and the magnetic field. Electric field and the magnetic field, which are perpendicular to each other. That means they are going to produce a crust and a trough in this way. And this, the distance between two waves are called as what? Lambda. It is represented by the symbol lambda, that means a wavelength. It is the distance between two waves. Distance between two waves, that means two crust or two trough. Two crust or two trough, that is called as what? Wavelength. It is distance between the two waves. And the next term we have to discuss, that is frequency. That means in the given time, the number of waves which are produced in the given time are represented by what? Frequency. Wavelength is the distance between two waves, two crust and two troughs. And frequency is the number of waves produced in the given time. And both of them are perpendicular to each other. Both of them are perpendicular to each other. That means as the wavelength increases, the frequency decreases. Or the wavelength decreases, the frequency increases. Let us see how they are perpendicular to each other. For example, this is the source of a vibrating body. Vibrations are taking place from here. So it is going to produce waves. If you look at from the source, the distance between two waves, right, it is going to decrease gradually. It is going to decrease gradually. The wavelength is going to decrease. And when you look at to the time, given time, the number of waves produced in a given time is going to increase. The number of waves are going to increase when the wavelength is decreasing, right? The height of the wavelength is not going to be the same in the beginning and at the end. In the beginning, whatever the height of the wave is there, right, that is not going to be there at the end of the wave. This is what we are going to observe even in the water waves. The beginning wave height is not equal to the wave height of the end wave. Right? This is what they are perpendicular to each other. They are perpendicular to each other. Right? For example, you have the sound waves. A medium is required. Without a medium, right, the sound waves cannot travel. Sound waves cannot travel in the vacuum because there are no particles to carry this sound. Right? In the same way, water waves, even water cannot travel through vacuum because it does not exist in that state. Right? It does not exist liquid in that vacuum state. And moreover, this electromagnetic wave, right? What we are saying, why we are saying it is electromagnetic wave? Because these waves produces what? Electric field and the magnetic field. When a charged body vibrates, it produces electric field and the magnetic field, and hence it is called as what? Electromagnetic wave. And this electromagnetic wave does not require any vacuum. It travels through, it does not require any medium. It even travels through the vacuum. Electromagnetic wave travels through what? Even vacuum. But not, but the sound waves or water waves, they cannot travel through the vacuum. But electromagnetic wave travels through the vacuum. So whatever the waves are there, right, there we do not have only one wave, we have many waves. Say for example Vibgyor. That is what we see during the rainy seasons, right, rainbow. So whatever the colors you see in this rainbow, right, violet, indigo, blue, green, orange and red. So these colors have different wavelength. Different wavelength. A group of waves with a different wavelength, right? A group of waves with a different wavelength are called as what? Electromagnetic spectrum. What is electromagnetic spectrum? A group of waves which are differing either in wavelength or frequency are called as what? Electromagnetic wave. And this electromagnetic wave travels through vacuum with the same speed, irrespective of the wavelength. Irrespective of the wavelength. Earlier what we have discussed here, wavelength and the frequency are inversely proportional to each other. They are inversely proportional to each other. They are inversely proportional to each other, right? So here in this electromagnetic spectrum, as we discussed, they travel through vacuum. They travel through vacuum. Now, if you look at each and every color has got a different wavelength. Say for example Vibgyor. In this Vibgyor, violet is having 400 nanometers wavelength, and moreover red color is having 750 nanometers of the wavelength. But when this Vibgyor is going to travel through the vacuum, it irrespective of the wavelength, it travels through the same speed. It travels through the same speed, that is called as speed of light, which is represented by the alphabet C, and the value given for this is 3 into 10 to the power of 8 meters per second. Let us recall this definition once again. This electromagnetic wave or electromagnetic radiation, when it is traveling through the vacuum, irrespective of the wavelength, they travel with the same speed. It is not 400 nanometers or 700 nanometers, they are going to travel with the same speed. And that is called as what? Speed of light, represented by the alphabet C, and the value is 3 into 10 to the power of 8 meters per second. And that's why here this proportionality is represented by lambda is equal to C by nu. Lambda is equal to C by nu, and this can also be written as C is equal to nu lambda. C is equal to nu lambda. Okay. So here we are till now we studied about the wave nature of the electromagnetic radiation. How this is traveling. How this is traveling. It doesn't require any medium, light, water and sound. Right? We have come to a conclusion that it does not require any medium. Right? Even in the vacuum it travels. It travels. Let us move to the another thing, that is about the spectrum, visible spectra and electromagnetic spectra. What are the things available in it now? In the electromagnetic radiation, a wave is produced from the charged body, right? The charged body. It produces electric field and the magnetic field, which are perpendicular to each other, and the distance between two crust is called as a lambda, and the number of waves produced in the unit time is called as a frequency, and the length of that wave is called as what? Amplitude. And also we have studied about the electromagnetic spectrum. Group of waves with the different wavelengths together, they are called as what? Electromagnetic spectrum. Let us see what is electromagnetic spectrum, what are the different waves we have, and what is the different wavelength we have in it. Okay? Electromagnetic spectrum. What is electromagnetic spectrum? A group of waves with a different wavelength. The different wavelength is called as what? Electromagnetic spectrum. And here are a few spectra, waves like gamma rays, X-rays, ultraviolet, visible light, infrared, microwave, and radio wave. Here are the few electromagnetic spectrum we are going to discuss it, right? Gamma rays, X-rays, UV rays, visible light, infrared, microwave, and the radio wave. Now each of them have got a different wavelength, right? Different wavelength. All together we are calling it as what? Electromagnetic spectrum, which is going to produce electric field and the magnetic field. Now here gamma rays will represent with the shortcut, right? G, and X-rays X, UV will write it as U, visible will write it as V, and IR will write it as I, and microwave will write it as generally M and R here. So we'll try to remember the order, code, okay? Here I am going to give you the small technique to remember the code. Right here, G, gamma, X, X-rays, U, UV, V, visible, I, IR, infrared, and M, microwave, and R, radio wave. Now here I say this as a generally X, U, V is my range, right? Someone says, if anybody asks you, right, which is your favorite car? So someone says a different models you are going to say here. But here, this is the code to remember the order of this electromagnetic spectrum. Generally, X, U, V is my range, right? General X, U, V is my range. This is the order to remember the wavelengths. Now coming to this gamma rays, X-rays, UV, visible, infrared, microwave, and the radio wave, which is having a shorter wavelength. Now gamma rays have the shorter wavelength. The one which is having the shorter wavelength, I said wavelength and frequency are inversely proportional to each other. So definitely there will be what? Higher frequency or the longer frequency, right? The frequency will be higher frequency. Then what will happen to the radio waves? Radio waves will have the higher wavelength, and then we have shorter frequency. Right? As you move from gamma rays to radio waves, what is going to happen to the wavelength? Wavelength increases and frequency decreases. Wavelength increases and frequency decreases. And here we have the visible spectra. We have the visible light. So what is this visible light? What are the colors you see in your daily life, right? In this world, whatever you can see, that is because of this visible spectra, right? All these gamma rays, X-rays, UV rays, infrared, microwave, and radio waves are passing, right, in this room. Even in this room, all these waves are there, but we cannot see them. Only we can see is because of what? Visible spectra, visible range, that is 400 nanometers to 750 nanometers. So our eyes are able to see the objects, detect the colors or identify the colors, that is ranging in 400 nanometers to 750 nanometers. That is the visible spectra. Already we have discussed, that is VIBGYOR. VIBGYOR comes under visible spectra. Right? Let us see in detail. So gamma rays, X-rays, UV rays, visible light, infrared, microwave and the radio waves. So visible light ranges from 400 nanometers to 750 nanometers. That is VIBGYOR. Right? It ranges from 400 nanometers to 750 nanometers. 400 nanometers to 750 nanometers. Where we are able to see the colors, we are able to detect the colors. Now see here, violet, indigo, blue, green, yellow, orange and red. They are ranging from 400 nanometers to 750 nanometers. A group of waves with a different wavelength are called as what? Spectrum. So it is visible, hence we are calling it as what? Visible spectra. Right? What are the colors? Violet, indigo, blue, green, yellow, orange, red, that we are able to see them. They are called as what? Visible spectra. Gamma rays, X-rays, ultraviolet, infrared and microwave and radio waves, we are unable to see them, right? They are not visible to the naked eye because of their wavelengths, right? And coming to the radio wave, we say that FM, right? Many of us are fond of listening to this FM. What is this FM? That is frequency modulation and amplitude modulations. Frequency modulation and the amplitude modulations. Let us see once again about this wavelengths, right? Wavelengths. Let us write the wavelengths, shortcut wavelengths here to remember them easily. Gamma rays, X-rays, UV rays, visible light, infrared, microwaves and radio waves, right? So we'll try to write its wavelength in meters now. It is 10 to the power of this 1 to 10 to the power of minus 3, and here we can write it adjacent to this one. This 10 to the power of minus 1 can be written to this side to remember it easily, and here it is 10 to the power of minus 4. The same thing again you write it here like we written 10 to the power of minus 1 to this side. Now 10 to the power of minus 4, and infrared we can write it here 7 into 10 to the power of minus 7 meters too, and visible range is from 4 into 10 to the power of minus 7 meters to 7 into 10 to the power of minus 7 meters, and coming to the ultraviolet it is 10 to the power of minus 6 to 4 into 10 to the power of 7, and coming to this X-rays it is 10 to the power of minus 8 to 10 to the power of minus 6, and coming to the gamma rays it is 10 to the power of minus 11 to 10 to the power of minus 8. This is how we remember their wavelengths, right? Radio waves are ranging from 10 to the power of minus 1 to 10 to the power of minus 3 meters. Now microwave rays, they are ranging from 10 to the power of minus 4 to 10 to the power of minus 1. Infrared 7 into 10 to the power of minus 7 to 10 to the power of minus 4, and visible light is ranging from 4 into 10 to the power of minus 7 to 7 into 10 to the power of minus 7. This is the visible range. Here we have written in the nanometers, and here we are writing it in the meters, and ultraviolet ranging from 10 to the power of minus 6 to 4 into 10 to the power of minus 3. So here you have given different waves with a different wavelength, altogether called as what? Electromagnetic spectrum. Altogether called as what? Electromagnetic spectrum. And here different colors with a different wavelength, altogether they are called as what? Visible spectra. So what is visible spectra? VIBGYOR. What is electromagnetic spectra? Taking from gamma rays to the radio waves, they are what? They are called as what? Electromagnetic spectrum. So this is what about the spectrum, visible spectra and electromagnetic spectra, and in next class we are going to study about the spectra based on energy and the wavelength. Thank you.